We are working on fractions in algebra. So a couple things. This is a fairly lengthy section, so stick with me today. Just to clarify a couple things, we have a fraction numerator over the denominator, and this is equivalent to 3 divided by 4. So it's the top divided by the bottom. We're going to be keeping things in fractions for the most part in this class. I'm rarely going to have you convert to a decimal by dividing the top by the bottom. The only time I'm probably going to have you do that is when we're working with percentages. And I want you to get really comfortable with fractions because they're going to be hanging out all the time for the rest of the year. And in addition to that, the PCC math placement exam is very fraction heavy, so I want you to be comfortable with that. So, first off, dealing with a mixed number and turning it into an improper fraction. So 3 4/5. So it's important to note that 3 is actually 5/5 3 times. So what I'm going to do is take this denominator and multiply it by 3. So 15. And then I'm going to add that to the 4. So 15 plus 4 equals 19/5. So if you look at it this way, I have 5/5 plus 5/5 plus 5/5. So that's 1 whole 1, 1 whole 1, and 1 whole. So 1, 2, and 3 plus 4/5. And we'll talk a little bit later about adding fractions, but the denominator stays the same. So I have 5, 10, 15, 19/5. So this is the faster way of doing it. Multiply the denominator by the whole number and add the numerator. And 19/5 is your answer. I prefer things left in the improper fraction simply because when you are adding, subtracting, dividing, multiplying, you have to have it in the improper fraction as opposed to using it as a mixed number. Just to do my due diligence, improper fraction to a mixed number, you divide the top by divided by, not square root sign, sorry, divided by 5. 5 goes into 48 times with some remainder, so 8 times 5 is 40, minus those 2, and you're left with 2, and that is your remainder. So 8 remainder 2. So when you convert that, 8 is your whole number, and you have 2/5 left over. As I mentioned before, though, I don't really want you to convert things to mixed numbers. I want things in the improper fraction form. So stick with that, and you'll be good. Prime factorization, I'm going to show you 2 different ways to do it. And then the reason you need to know how to do this is so you can reduce or add or subtract fractions. So the prime factorization, there's one way to go about it, particularly, actually I need to have, hang on. So I'm going to treat this as though you don't know anything off the top of your head, any of your multiples or anything like that. So by multiples, I mean numbers that multiply together to give you that number. So if you're ever trying to figure it out, you can always just divide. So if it's an even number, some 2, 4, 6, 8, 10, anything that ends in a 2, 4, 6, or 8, or a 0, you can always start by dividing it by 2. So 100 divided by 2, which gives me 50. So I can split this is one way to do it, into 2 and 50. 2 is a prime number, so I don't need to do anything with that. And then 50, I can divide by 2. And I can divide that, so that's 2 and 25. 25 is not divisible by 2, so I can, if I don't know off the top of my head, I can do 25 divided by 3, not a whole number, 25 divided by 4, not a whole number, and 25 divided by 5, which gives me 5. So that divides into 5 and 5. So 2, 2, 5, and 5. So the prime factorization of 100 is 2 times 2 times 5 times 5. Now, the other way I'm going to show you is a way of listing all of your factors. And this is really, really useful when we're doing factoring much later on with polynomials and quadratics and that kind of thing. So you always start with, always start with 1 and the number, 1 and 100. And then you go to 2, 2 and 50. You go to 3, it's not divisible by 3, so I'm not going to use 3. Then I go to 4. 100 divided by 4 gives me 25. 100 divided by 5 gives me 20. So 5 and 20. If it's not divisible by 3, it's not going to be divisible by 6 either. And then 100 divided by 7, I already know that's not. 100 divided by 8, 100 divided by 9. So I'm left with 10 and 10. And that's right there how you know you have all of your factors. Is it either these two numbers are the same or they flip places, and I'll show you that in just a moment. And if you wrote these two numbers down, you notice I changed them twice, so just be aware of that. This method is going to help you probably the most in reducing your fractions. This method is simply listing all of the possible factors. So this is technically the prime factorization right here. So 24 is divisible by 2, so 2 and 12, because 24 divided by 2 is 12. 12 is divisible by 2, so 12 divided by 2 gives me 6. 6 is also divisible by 2. 2 and 3. 3 is a prime number, meaning you can't multiply anything by itself, anything other than 1 in itself to get that number. So your prime factorization of 24 is 2 times 2 times 2. So it's 2 times 2 times 2 times 3. If I'm simply listing the factors of 24, 1 and 24, 2 and 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 25 is not divisible by 5. And then it's back to 24 divided by 6, which is 4. So once these two flip around, you can't see what I'm pointing to. Once these two flip around, my next factor is 6 and 4. Then I know I have all of my factors there. So 27, the factors of 27 are, I'm going to do it this way first, 1 and 27, not divisible by 2, and then 3, 27 divided by 3 is 9. And that is actually all your factors for 27. If I look at the prime factorization, so we know it's divisible by 3 and 9. 1 and 27 doesn't help us much in that process. 3 is a prime number, and then the factors of 9 is not divisible by 2, but it is divisible by 3, and that's 3 and 3. So 3 times 3 times 3 is the prime factorization of 27. So reducing your fractions, this is helpful. Knowing those factors is helpful in this process. So what you're looking for are numbers that both the top and the bottom are divisible by. So if I look at 10 and 15, those are both divisible by 5. If you don't know these numbers off the top of your head, that's fine. You can get a multiplication table. They're in the back of most composition books, or you can make one yourself. And you can start to look for those numbers and what both of those are divisible by. The first one you want to look for is 2. 15 is not divisible by 2, so that doesn't help me much. But anything that has a 0 or a 5 at the end is going to be divisible by 5 as long as it's greater than 0. So basically what I'm doing here is putting this in the prime factorization. So if I do the prime factorization of 10, 2 and 5, and that's that's all I can do. 2 and 5 are both prime numbers. And then 15, whoops, is not divisible by 2, so then I'm left with 3 and 5. And in that case, so that one is also its prime factorization. So if I rewrite this as 2 times 5 over 3 times 5, here's a wonderful thing that happens. Any number divided by itself is going to be 1, and 1 times anything is going to be that number. So this, some people refer to it as canceling out. I prefer divides out to 1. Either way, those 2 5s, when you're just multiplying, those go away. So my reduction is just 2 over 3. The other way I teach this is both of those are divisible by 5, so I divide the top by 5, which equals 2. Divide the bottom by 5, which equals 3. Either way is fine. 42 and 24, I'm going to go ahead and factor those, or do the prime factorization for those. So 42 divides to 2 and 21. 21 divides to 3 and 7, and those are all prime numbers. So this is 2 times 3 times 7. 24, 2 and 12, 2 and 6, 2 and 3. So 2 times 2 times 2 times 3. So these 2's divide out. The 3 and the 3 divide out. So what I'm left with is 7 over 2 times 2, which is, I'm going to have to bring this whole thing down here because I'm out of space. So 7 over 2 times 2, which is 7 over 4. And I'm going to leave it just like that because I don't like mixed numbers. (13 over 15). 13 is a prime number, so there's nothing I can do with this one. That one is what it is. 9 and 45. 9 has a prime factorization of 3 and 3. So what I can do is just start with 3 in that 45. I don't know why I drew the line there. It's not necessary. So 3 and 15. And I don't need to continue to factor that if, well, yeah, never mind. Just kidding, I do. So 15 is 3 and 5. So this is 3 times 5. And here's where I need to be careful. Because these 3's divide out, those 3's divide out, and I'm left with 5. But it's on the bottom. So this is not 5 as my overall answer. Instead, it's going to be 1 over 5, or 1/5. That is the end of the first part, and we have 3 parts. So join us for the second video in a few minutes.